And the last time we met, we talked about data types. Before that, we had talked about introduction to Python, and talked about what Python is. So today, before we start on storing data in Python, I would like us to first talk about functions in Python. So functions in Python are also called methods. They're methods or functions. And functions, I'll teach you how to build them. So functions in Python are also called functions. We build functions in Python using the def keyword, or define, but just call it the def keyword. It is used to build functions. So let me enter into presentation mode. So I'll start. Let me move this down here. So we build functions in Python using the def keyword. Let's say I want to build a function called my function, so I'll use def my function. And we'll finish up with a brackets or parentheses, then at the end we use a colon. Then inside the function you can place in statements. Let's say print hello world. Sorry. Print hello world. Just like that. Then at the end, we call our function. Down here, let me say print, and then the name of my function. So this is the simple syntax of our function. You can see it has printed our hello world down here, but down here we also have another statement called none, meaning I've not used the return statement, so it returns nothing or none. So a function must be called with the correct number of arguments. If it expects 2 arguments, give it 2, not more, not less, or else there will be an error. What I mean is that, let me say, building a function to calculate the sum of 2 numbers. So I'll start by building a function. Let me call it add up. Then into my function, I'll pass my 2 arguments, which are 2 variables, which will be numbers. So let me say x and y. Then at the end, we use a colon. Down here, we'll tell the function what to do. So in our case, it's adding up 2 numbers, and the 2 numbers are x and y. Let's say x plus y. Then we'll use now a return statement. A return statement is used to return something. So in our case, it will return the sum. Then after that, I can tell the user to enter the input. So I'll say something like x is equals to where I want the user to enter their input. So x is equals to which will be an integer, then input. And you can leave it like that, or you can say enter your first number. Sorry, I've not put it in quotes. Also, you're seeing the red marks. So this is my string. So enter your first number. Then after doing that, I'll come down here and say y is equals to, it should also be an integer. Then I ask for the user's input. Oh, sorry. So I'll say enter your second number. Then back here, I must use a parenthesis. Then at the end, I will call my function. Calling my function is where you want it to operate now. So I'll say I want to print the sum. So I'll say print, meaning I will want it to display the sum of the two numbers on the user's console or to display it to the user. So I'll say sum, then I call my function, then I specify the arguments, which is x, y. Then when I run this code, let me see, my first number is 10. Then 10. Then my second number is 20. It will return for me the sum. In my case, 10 plus 20 is 30. So because I've used the return statement, the return has a value. So it's not empty and it will not print to me none. That's why I've said a function must be called with the correct number of arguments. In my case, I've used 2 arguments, x and y. At the end, I'll have to use the 2 arguments, which are x and y, not more, not less, or else it will give for me. Let me say, for example, I've called 1, and I run it to tell me enter, but it will bring to me an error because I've not specified the second argument. So you have to specify the correct number of arguments for your code to be correct. Yeah, this time we learned about data types. Then in Python, there are different types of functions. There is the inbuilt function, like print here. In our case, print is another inbuilt function is the input function. There are very many inbuilt functions which you can use in Python. You can also download functions using the modules. You can also download functions from modules, and you can call them using the import statements. We'll learn about this later on. Then, as you can see, our third type of functions, the user-defined functions, like the one I've created here, it's a simple user-defined function. A Python function will always have a return value. In my case, I've returned the sum. So our Python function will always have a return value. There is no notion of procedure or routine in Python. If you don't use a return value in a return statement, if you totally omit the return statement, then Python will implicitly return a default value for you. The default value is always none. If you don't use a return statement, the default value is none. A function without a return statement will print nothing. It has no return value, so it will print none. I'll give you an example. In our case here, the return has a value, but in a case like this, let me say, let me create a function called print something. Yeah, print. Can you hear me? Print something. Sorry, print something. I will create a function called print something, and I'll pass in an argument s. I've said we'll create a function that has no return value, so it will print none, or it will not print. Okay, it will print none. So in my example, I'm going to create a function called print for something, and I'm going to pass in an argument called s. Then inside I will give it a statement saying print. Then I will pass into the thing my argument saying printing. I want to printing, then some 2 columns, then space, then an s, which I pass it in the argument. Then after that, I won't use any return statement. So I'll create a variable called output. I'll create a variable called output, and output, I'll say print something. Let's say hi. After that, so this will write or display printing hi. Then after that, I'll pass in the print with the F format. Then a function without a return statement. Just like that. Then I'll say a function without a return statement, then returns. Then I'll call in my output variable. When I run this code, you'll see what I mean. Hi, when I call the second time the function without a return statement, a function without a return statement returns none. You can see the output. I created an output variable and passed and called in my function, which has no return statement. So when I use it again, it will return none, or it has no value. So just like that, that's how you work with function. We'll learn more about function later on in our advanced Python. So right now, I was just telling you we have 3 types of functions. We have the inbuilt functions, user-defined functions, and you can download also functions through modules using the pip statements. I'll show you an example. Let me say I want to download a QR code function. So I'll come down here in my terminal. You can either, if you're using Linux, you can just go and download it from the Linux or any Linux distro terminal. But also you can download it. You can download it on your Python interpreter, your Python IDE, in my case PyCharm, at the terminal, and you pass in the command pip install. I want to download a QR code module. I'll say install QR code. So this module can be used to turn text into a QR code, or you can turn links into QR code. So I won't use it, but I'm showing you how to download a module So I've downloaded the module. In my case, it has finished downloading. So to use this module, I'll import it first. So I use the import statement, import QR code, you can see. Just like that, then you can use it. I won't show you how to use it now. We'll learn about it later on. But that's how you download a module. So I've said a function without a return statement prints none. It will always print none, but a function with a return statement will print the return value. So let's move on. In today's topic, we are going to learn about storing data in Python. I've taught you about Pythons, but we are going to learn right now about variables. We use variables to store data in Python. I'm going to show you how. So storing data in Python, I've said what are variables. So in the above bookshelf, we have an example of a bookshelf in our case. And in the above bookshelf, we can see many sections which are precisely labeled. So if you want to place a mathematics book, we'll keep it in the section labeled as mathematics, right? The above bookshelf can be used to store the books we want. So what they mean here, you can see there is a name called mathematics, physics, chemistry, biology. So if we take this into a practical examples, these are variable names. These are variable names. Variables have names. There are specific rules for naming your variables. So similarly in programming, variables act as containers to store variables, just as I've said. These values can be anything from numbers to text to entire functions to decimal numbers. And just like the labels in case of the bookshelf, variables are identified by variable names. The values stored in the variables can be used further in our programs. How? We can retrieve them by referring to the variable name which are used to identify these variables. So that's very easy. I'm going to show you in a minute. So what they mean, I'm going to open my PyCharm, then enter presentation mode. So I'm going to create a variable. I'm going to name this variable 1. Then in this variable, I'm going to assign it a value using the equal sign or the assignment operator. And I'm going to call this variable, I'm going to assign a value. I can assign either an integer or a string. So I'm going to assign it a string. To assign a variable a string, you use the quotes. You can use double or single quotes. I'm going to use single quotes. So I'm going to call this variable 1. I used a variable for this. Then I'm going to print it, or I'm going to display this to my console. So I'm going to write print. Then I'm going to write the variable 1. So when I run this code, you can see saying I used a variable for this. So this is my variable name. Sorry, this is my variable name. I call it variable 1. This is my variable. I've called it variable 1. Using the assignment operator, I've assigned it a string. Its data type is a string, but I can also assign it when I assign it an integer, I don't use the quotes. You only use the quotes when assigning a string. So when I run this code, it will still print the integer, which is 5. I can also assign it a float, which is 5.54. When I run this code, you see, it still prints the float. So you can assign your variable any data type. So this is very easy. You don't need to specify as as in other languages. So in Python, you don't need to specify the data type. You just create the variable and you assign it the data type. If it's a string, you use quotes. But for a float, an integer, you just write it as it is. So I'm going to go back to our text. So similarly, let me present this. Similarly, in programming, variable act as containers to store data, just as you have seen. In our example of the bookshelves, there are these containers. Let's say the maths holds some specific types of books, math book. Then physics holds these types of book. So these are containers which are holding books. Same to variables in Python. These are containers to store values. These values can be anything from numbers, which are integers, to text, which are string, to entire functions. So, and just like the labels in case of the bookshelf, variables are identified by variable names. The values stored in the variables can be used further in our programs. You are asking how? We can retrieve them just as I've retrieved in the case where I called in the print function and retrieved my variable, and it printed what I wanted it to print. So we continue. Variables in Python can be referred using variable names or address of variables. This is a question. Variables in Python can be referred using, so it's true, variable names. Storing data in Python, still the variable name, value, and assignment operator are the three things required to store values in the variable. So in our example, they have created a variable called myVar, and the assignment operator, and they have given it a value of 60. In Python, variables don't have to be declared, but in other language like C++ and Java, you have to declare your variables. Let's say like an integer, you have to specify an integer variable. String, you have to specify a string variable. Character, like that. So you can also store text in variables. Text values are known as strings in programming. A string is a sequence of characters. The characters can be a letter or a number, even a special character. Let's say a question mark is a string. So anything written between quotes or single quotes, double quotes or single quote is a string. So as you can see, they have created a variable here and they have given it a string as a value. So the variable is called myVar1, and they have given it a value hello as a string. It's supposed to be my variable 1. My variable 1 is a variable. Can you hear me? So they have passed here a string as the variable. So you can use, as long as it's in quotes, it will always be a string, double or single quotes. So there's a question here, proper syntax of declaring a variable is. So as you can see, it's variable name is equals to variable value. You can also store numbers in variables. Numbers containing a decimal point are known as floating point numbers in programming. There are double floats, but in Python we use floating point. So any decimal number is called a floating point, a floating point number in programming. A floating point number refers to a number consisting of two parts separated by a decimal point. a whole number is known as an integer. So there are integers and floats. So you can store floats, you can store integers in variables. Let's see how numbers are often stored. So you just write the number without anything else. So this is an integer, like the whole number, which is 2, is an integer. Then 25.54 is a float. Regardless of the type of number, whether a floating point or an integer, Python views them as a single category, numbers. So Python automatically identifies the type based on values, and we do not need to specify the type manually. Unlike C++, where you have to specify, let's say it's an integer, it's a float, you have to specify. In Python, you just write, the interpreter identifies by itself. That's how different types of variables can be created in Python. So let's go to questions. Which of the following are not floating point numbers? So I've said floating point numbers are decimals. Whole numbers are called integers. So it's very clear. 3 and 4 are whole numbers. So these are not floating point numbers. How can you create a variable named your variable or your var and assign it a value 45 in Python? So you don't have this. The first one is wrong because they have specified the type of value. In Python, we don't specify the value. Second one is wrong because they have used double equal sign. This is called an is equal to. It's not an assignment operator, so this is wrong. So the third is right. Your variable, your var, which is 45, the value is 45 using the assignment operator, which is only a single equal sign. What is the correct way to declare a string in Python and assign it a value hello? So you have seen to create or to declare strings, you use the quotation marks, then the variable name and the assignment operator. The first instance is very wrong. They have specified or they have said they've used the string keyword using then new var, which is very wrong. Then hello inside the brackets. All of this, the syntax is very wrong. Then the second one is correct because it has the correct syntax, which is the new var equals to then hello inside the quotation mark. Can be double quotes or single quotes. The third one is wrong. There is no quotes. Even the syntax is very wrong. And the last one, it's an inverse, which is also wrong. The correct answer is the name of the variable, which in our case is new var, then the assignment of operator, equal sign, then the string inside the quotes. Then the other question, which of the following statements are true for a variable? Which of the following statements are true for a variable? So you pick all that are correct. So is variables can be numbers and strings? Can variables be numbers and strings? Are variables containers? Variables are used to store data, or are variables in Python needed to be declared? So you see the first three statements are correct. In Python, we don't need to declare variables. The interpreter knows knows the types of variables by itself. Then to summarize, in programming, variables are containers which can be used to store values. Values can be numbers or strings. Strings are written inside double quotes or single quotes. These variables are referenced using their variable names. That's the end of our first presentation. Today, we are also going to learn about decision making in Python. We have learned about storing data in Python. We store data in variables. We have said variables are containers. So we're going to learn about decision making in Python. So how do we make decisions in Python? It's very simple, very easy, very precise. What is decision making? we subconsciously make decisions in everything we do. For instance, should I eat? If yes, what should I eat? Pizza? Yes. Not hungry? Sleep. Those are some types of decisions. So let's say I'm very hungry. So should I eat? Am I that hungry? And if yes, if I'm to eat, what should I eat? Then pizza? Yes. But if I'm not hungry, I'll just sleep. Can you count how many decisions you have made? So in our case, these are only two decisions. In our case, these are only two decisions. So let's move on. Making decisions in Python. Just like we make decisions in our daily life, our program also needs to make decisions. To make decisions in Python, we have decision-making statements. The decision-making statements provided by Python are if else, if, ELIF, or else if. Let's see how we can use this to help our program to take some decisions. So we are going to learn about decision making or conditions. So there's the if else, or if and ELIF, or if else if. So an if statement can be used to check if a condition is true or false. If the condition evaluates to true, the code block following the if statement is evaluated. Do you remember what the true or false means in Python? Yeah, true or false is a Boolean data type, or bool. In our case, if and else can help define the bool data type. So an if statement can be used to check if a condition is true or false. If the condition evaluates to true, the code block following the if statement is evaluated. In Python, to indicate the block of code, indentation is used. So I would like you to take note of this. Indentation is very important in Python. You can find many errors which are very simple because you did not indent your work. Indentation means spacing, let's say from the margins. Yeah, spacing from the margin. So in Python, to indicate the block of code, indentation is used. So each line must be indented by the same amount in a block of code. A typical if statements look like this. So if condition, a colon, then indentation. You have seen from the spacing here is different from the if condition. So statement if true. So remember to always indent your work. Most errors can be simple because of this indentation. A colon is used in Python to make the code more readable and separate the different parts of expressions. Let's understand if statement using an example. Then we have a simple question here. What is used to represent a block of code in Python? What is used to represent a block of code in Python? It's very easy. Indentation. Indentation is used to represent a block of code in Python. As I said, it's very important. You need to take care of this because it can bring you very simple errors, which can be avoided just by indenting your work, or can be corrected by just indenting your work. So let's move on. An if statement can be used to check if a condition is true or false. If the condition evaluates to true, the code block following the if statement is evaluated. So you'll say that true or false statement is an example of a Boolean data type. Boolean data type returns true or false. In Python, to indicate the block of code, indentation is used. So indentation is very important. Without indentation, you can get very many errors. A typical if statement looks like this. The if condition, a colon, don't forget the colon is very important. Without this colon too, it won't work. It will print you an error because this colon separates these two parts, separate the condition from the statement. Without the colon, meaning there will be no condition, there will be no statement, just be one block of code. It will print an error because it does not understand the syntax. So this is very important for the syntax of the if statement. So the if condition, colon, then the other thing is indentation. Without indentation, you'll also get errors. We have said in Python, to indicate the block of code, indentation is used. So without indentation, it will also give you an error. Unlike other languages like C++, where you use a semicolon in many areas, in our case, you only use an indentation in very few areas. That's why Python is very easy, simple, and very unique from other languages. So the if condition, don't forget the colon, don't forget indentation, then statement if true. Most interpreter or most IDEs will always automatically indent for you, but don't be cautious. Always look at such areas. Sometimes they can cause errors and they will not automatically do it. So you have to do it yourself. So let's continue. A colon is used in Python to make the code more readable and separate the different parts of expressions. So let's use an example. So there's a question here first. What is used to represent a block of code in Python? In Python, to indicate the block of code, indentation is used. So the correct answer is indentation. So there's an example here. We have a statement. So if statement, an if statement, I've said can be related to the Boolean data type. An example of an if statement or an if statement, I've said if 5, the 2 equal sign means is equal to, but 1 equal sign is used to put a value to a variable or to anything. So there's this is called an is equal to sign, 2 equal sign. 1 equal sign is called, what is it called? An assignment operator. Yeah, that's the word. So 1 equal sign is an assignment operator where it assigns a value, let's say to a variable. Let's say my variable name is number. Then I use 1 equal sign. Then I put 5. So I'll be have assigned my number variable the value of 5. But in our case, double equal signs mean is equal to. So in our it's used to compare. So in our case, we are comparing if 5 is equal to 5, which is true because 5 is equal to 5. So in the above if statement, the condition 5 is equal to 5 will evaluate true. And that's the following statement. So because this is true, this will be printed. So what if it's false? What will happen? It will not be printed. Let me show you an example. So we're going to use this example here. So in our case, we have said if 5 sorry. So in our case, I've said if 5, 2 equal sign operator, meaning is equal to 5, don't forget the semicolon. I've told you if you're using an IDE, if you're using an IDE, most IDEs will automatically indent for you, but don't forget to indent. Some might be having errors and they won't indent, but in our case it has indented. So print I have, sorry, this needs to be in quotation marks. I have learned conditional statement. Like that. So when you run this code, because it's true, it will print I have learned conditional statements. What if it's false? So let's say 5 is equals to 4. Let me say 5 is equals to 4. When you run this, it won't print anything because I've not used an else statement. So 5 is not equal to 4. I've not specified what if it's not true. I've not specified. Okay, it won't print because it's not true. So I can add another else statement. I can add an else statement. So else. So else print. Nope. So else nope. I'll just write like that because of time. When I run this, you can see because it's true, it will print the correct answer. What if 5 is not equal to 4? Or 5 is equals to 4, which is not true. What if the statement is not true? You see, it goes to the second statement. Nope. Because my first value is not equal. Okay, let me say my first, if condition is not equal or is not true, it will go to the next statement, which is what if the condition is false. That's the simple syntax of an if and else statement. So we'll go back to our document. So we are going to continue. How many minutes do I have? Let me check something. So let me see. So that's how you use an if and else statement. If the condition is true, the if statements, the statement under the if condition will be printed. But if the condition is false, the statement under the else condition will be printed. So in the above, if statement, the condition 5 is equals to 5 will evaluate to true. And if statement, okay, the if statement prints if the condition is true, or if statements will run if the condition is true. But if the condition is false, they have their else statement. Python has an else statement which will run. So in the above if statement, the condition 5 is equals to 5 will evaluate to true. And thus the following statement, which tells the program to output, you successfully learned if statement, will be printed on the screen. Equal to operator is used to compare two entities. Actually, there's an equal to and there's one equal sign, which is an assignment operator. Don't forget the two differences. There's an assignment operator and there's an equal to operators. I think we'll learn about operators in our next class. So if 5 is greater than 9, print, oops, not this time. So as you have seen, 5 is not greater than 9, so this statement won't run. In the above if statement, condition evaluates to false. That's the statement following if will never be computed. So I've said if only returns a value if the statement is true. But if the statement is false, it won't return anything. So the else statement returns the false statement. So as you have seen, there's the syntax here of using the if condition and the else statement, if and else. So an else statement is often used with if statement. In the case when the condition inside it evaluates to false, the statement under the else statement are evaluated. So in the case, as you have seen, the example I've done, when it evaluated to false, the else statement was printed. But if it was true, when it evaluated to true, the if condition statement was printed. Else is always written after if statement. So there cannot be an else statement without the if condition. So always write else after if. Else must be after an if. Let's understand it using an example. So there's a question first. Which of the following is not a decision-making statement? Which of the following is not a decision-making statement? So which of the following is not a decision-making statement? Which of the following is not a decision-making statement? I've said that for is not a decision-making statement. It's a loop. We'll learn about loops, I think, in our next topic. Consider the below snippets. You remember I told you you can build a simple AI using if and else statements. Just by telling you if this is done, print this. If that is done, you'll have to use very many if and else statements. But yeah, you'll have your AI at the end. It's not the conducive, but you can use it. A simple AI program. So if 5 is equals to 3, print, you have successfully learned if statement. Else, print, wow, you also learned about else statement. So I've said if the condition amounts to false, it will always print the else statement. In our case, this condition is false, it will print, wow, you also learned about else statement. So if you want to check multiple conditions, you can use ELIF statements. So instead of writing if, else, you can just write if, then ELIF, then else. So it's very simple. ELIF will always come after if statement. It cannot exist individually. Just like the else statement always comes after if, the same as ELIF. ELIF statements will be checked in the order in which they appear. So it will always start, let's say, from condition 1, condition 2, condition 3. That order. It won't start from the last condition to the first condition. It will always go in the reading mode order, where you start from the top to the last one. So there's an example. If 5 is equals to 4, print an if statement. ELIF 4 is equals to 4, print. That's something new. Else if 4 is greater than 9, print. Really? Else, print, not the same. So 5 is equals to 4. This statement is false, so it won't print anything. Else if 4 is equals to 4, this is true, so this statement will be printed. And if 4 is greater than 9, it's false, so really won't be printed. Else, print not the same. So it only prints this statement. But if two statements were correct, let's say if 5 was equals to 5 and 4 is equal to 4, these both statements will be printed. In case of if-else if block, the condition will be tested until a condition is found to be true. In above snippet, the second condition will evaluate true. Thus the output will be thus something new. If all the condition evaluates to false, then the else block will be executed, meaning if all these statements were not true, then it will opt to the last option, which is the else statement. Choose the correct output. If 14, you don't even need to go further. If 14 is equals to 14, print I love coding. If 41 is greater than is equal to 4, print I am learning how to code. Else if 4 is greater than 9, print what is Python. Else print not this time. So the first condition is true. So it will print I love coding. Arrange the if-else statements in correct order. So the if-else statement always start with an if. So I'll have to start with an if, and it ends with an else. So else will be below everything. So it will start with an if condition, then ELIF condition, then else condition. What will be the output of the following piece of code? If 5 is less than or greater than 4, print this. Else if 5 is greater than or equal to 5, print or this. So you can see 5 is greater than or equal to 5, it will print all this. An else statement cannot exist individually. It should always be preceded by an if statement. This is very true. An else if and an else statement do not exist individually. They need an if statement. We come to our last part, saying like humans, computers also have to make several decisions. Python provides if else, and if else decisions making statements. It can if can be used to test a single condition. Like humans, also computers also have to take several decisions. Python provides if else and if else decision making statements. If can be used to test a single condition, else is used to tell the computer what to do in case if statements evaluates to false. Not true, sorry. Suppose in case if statement evaluates to false. In a situation where we need to check multiple values, if ELIF statements can be used.